2020 question 33. Refer to the following chemical reaction. And so here you see that water is being dissociated to form hydrogen ions and hydroxide ions. And delta H is greater than 0, which means this is an endothermic reaction. The pH of a pure water sample is 7 at 25 degrees Celsius. Which of the following statements is or true when the sample has been heated to 15 degrees Celsius? So here, heated up to 50 degrees Celsius, so you can see the temperature has increased. So T stands for temperature, the temperature has increased. Now let's see option 1. It says that the concentration of hydroxide ions of the sample is 1 times 10 to the power negative 7 mole per dm cube. Now, actually, the concentration of hydrogen ions and the concentration of, actually, it should be equal to the concentration of hydroxide ions when the pH is 7 at 25 degrees Celsius. This is definitely true. It's going to be equal to 1.0 times 10 to the power negative 7 mole per dm cube. This is what you have learned in book 2A in the topic of acids and alkalis. But here, it says when this of the sample, that means when it is heated up to 50 degrees Celsius. And you can see it's in equilibrium. So we need to factor in what we have learned in book 4B about the equilibrium position shifting. So here, remember, this is an endothermic reaction and the temperature increases. So the hint that I gave you back then was when it's endothermic, obviously we know it's positive. When there's an increase in temperature, that means this is positive. When there are two positive, you times two positive together, it will favor the right hand side, meaning it will favor the product side here. So everything, the equilibrium is going to shift on the right hand side. When the equilibrium shifts on the right hand side, what does that mean? That means obviously the concentration of hydrogen ions here, it's going to increase, and the concentration of hydroxide ion is also going to increase. Now, is the concentration of the sample of it's the concentration of hydroxide ion that's going to be 1 times 10 to the power negative 7? No, it's going to increase. So it's not going to be the same. It's going to change. Option 2 now. The pH of the sample is smaller than 7. Okay, here. The answer is already right in front of you, actually. We have just figured out that I have increased the concentration of hydrogen ions and the concentration of hydroxide ions. So pH, what is pH again? pH is equal to negative log the concentration of hydrogen ions, right? Now, what's the concentration of hydrogen ions? Obviously, just like I see here, I have increased the concentration of hydrogen ions, right? So, to give you some numbers, to make it more simple, let me give you some numbers for that. So at 25 degrees Celsius, the pH, or I should say the concentration, maybe I'll say the concentration of hydrogen ions was equal to 1 times 10 to the power negative 7 mole per dm cube. So I'll just write capital M, will I write for mole per dm cube? And how about at 50 degrees Celsius? At 50 degrees Celsius, as mentioned earlier, the concentration of hydrogen ion has increased. So let me say it's 1 times 10 to the power negative 5 now. It's 1 times 10 to the power negative 5. So now I'm going to input this 1 times 10 to the power negative 5 to my pH calculation. So here, what am I going to get? Negative log 1 times 10 to the power negative 5. And when you input it in your calculator, you should see that the pH now is 5. Now, obviously, this number is smaller than 7. So statement 2 or option 2 is correct. Okay. Now, option 3, the final option, it says the sample, however, remains neutral. Is that true? Yes, it does remain neutral. Because remember, at the end of the day, as I wrote here, the concentration of hydrogen ions is going to be equal to the concentration of hydroxide ions. So at the end of the day, the sample, even though right now the pH is 5, right? Even though pH is 5, you're like, sir, it doesn't make sense. The pH should be 7. But no, remember, you have increased the concentration of hydrogen ions, but at the same time, you have also increased the concentration of hydroxide ions. But at the end of the day, they're both going to be the same. So you can say in a way the effect cancels out one another. That's why the sample remains neutral as well. All right, so here, this was a very tricky question, but it includes the concept of book 4b, which is the equilibrium position shifting. That's why you might get confused here. But at the end of the day, it's still using all the calculations you've learned before. So this question, the answer is D.